My name's Dr. Seth Hubbard. I'm an assistant professor here at the Rochester Institute of Technology, and I'm also a member of the NanoPower Research Labs here at RIT. The NanoPower Research Labs, or NPRLs as we call it, is particularly involved with aspects of energy conversion, energy storage, energy generation, and energy transmission. And all of these aspects of sort of energy, we're looking at the use of nanomaterials. In general, I think solar cells or photovoltaics provide some type of option for renewable energy in this country. The sun represents a tremendous source of power. Practically speaking, there's over 600 terawatts of energy available from the sun at any time. If we can just tap into a small portion of this, we could potentially be able to create all the energy that we need. However, it's not so simple, and the sun goes up and down each day, so there's a lot of technology that would be needed in order to do this. We need to be able to efficiently convert that energy from the sun and to be able to do it cheaply. We also need to be able to store that energy at nighttime when the sun is down and be able to transmit that energy to different parts of the country effectively. And so these are small topics that we look at here at the NanoPower Research Lab. One of these methods is actually putting nanostructures, or very small structures that are on the order of just a few atoms in size, into the solar cells. And so quantum wells or quantum dots are all variations of these types of nanostructures. We utilize quantum dots in our solar cells by actually epitaxially growing these or making these an integral part of the solar cell. And we do that through our collaboration with NASA Glenn Research Center down in Cleveland, Ohio. Once we've actually grown these quantum dots down at NASA, we bring them back up here to RIT. We use the Semiconductor Microsystems and Fabrication Lab over in the engineering building to actually produce our solar cells and put down the contacts, and then we bring them over here and we actually test them in this lab. And so we look at how they would work under a simulated sunlight condition. So since we can't go outside all the time and have a perfect day, we actually simulate it in the lab. The results that we've got using quantum dots has actually been very exciting. We're able to grow quantum dots in the material into the solar cell without disturbing the actual solar cell itself to a great degree, and the quantum dots actually provide more current by absorbing more of the sun's light and actually converting that into electrical power. Just in the last few years, because of the energy crisis, photovoltaics and renewable energy industry has grown dramatically, almost at an exponential rate. RIT is in a unique position to provide these industries the trained scientists and engineers that they really need.